Yeah.
All right, gang, we're back. I noticed looking back at those previous two clips, I was executed by the camera angle per se, so I enlisted the help of one of my bros, Sebastian. So big shout out to my boy for taking time out of playing Roblox to come help me out. Am I right? He's shaking his head, but it's true. Anyhow, let's get into sort of like a fun little application of these two things, all right? So if you guys have ever dealt with solving system of equations, and if you've taken a high school class, I feel like that's somewhat familiar. What the heck was that? Again, we're out in Mother Nature, so we're susceptible to the elements. And of course, I'm a country boy, so I'm used to these kinds of things, right, Sebastian? Anyhow, let's look at a little application, shall we? Let's not get entangled in all of that. And so again, where was I? Systems of equations. So let's see how we can use this to systems of equations. And it's interesting because how are these two things related? You know what I mean? Like this kind of thing, right? So we're all familiar with matrices, right? If you're looking at this, then the assumption is that you've kind of probably taken an initial linear algebra class. So you've probably heard of what a matrix is. Technically, in the book, it doesn't cover matrices until way after this, but I'm just going to introduce it for some context. And we all know that matrices are linear maps. So if we consider the linear map, T of x, based on some matrix x, A, what am I saying, times x, right? And let's say T is going from, we could say like Rn to Rm, okay? And these are, again, just your real vector spaces, where this is of dimension n, of course, this is of dimension m. And so what does that mean the dimension of A is? Well, if you know a little bit how matrix multiplication works, A would have to be, well, let's see, again, if x is n by 1, right? Because it's in Rn. So m would have to be, well, how does that work? If this is m by 1, this has to be m by n in order to make that matrix multiplication work, right? So let's do m rows and n columns. Great. Okay, so we have this linear map, right? Well, we can write that out, right? Let's say A has entries like Aij, where I is in the ith row, J is the jth column, right? This is usually how you denote a matrix, right? Then how does that multiplication work? Well, let's look at the first row, for example. So you'd have like A11, let's see, A12, dot, 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 and we'd have A1, and that's N, okay? And then all the way down here, right, you'd have your AMN, that kind of stuff, and this is your AM1. Okay, let's pick up the pace so my boy doesn't have to wait too long, get back to his Roblox, right? And so what we have here, that's our matrix, that's good. Now let's try to multiply that by x, okay? And so if x, let's say x is of the form like x equals, you know, your usual column vector x1 to xn, these are just scalars, holy crap. Anyhow, we have our scalars, our column vector, all right? And then again, how you multiply, you do that, you do row, column by row, right? So what you're gonna get, if I could clear some space for myself, get rid of some of the nonsense up here. What you're gonna get for this is multiply this guy by this guy, basically like considering their dot product, then go all along. You'll get something like this, and we know it's gonna be in Rm, so there's gonna be m components. You're gonna get A11, x1, plus, let's see, A12, x2, plus dot, 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 plus, and you know what, I'll express that in a simple way with sigma notation, okay? And so we can go from like I equals, say 1 to, it's gonna be to n, right? Because we're going n times, and that's gonna be A, let's say, it's gonna be 1i, right? And it's gonna be xi. And then here we're gonna do, it's gonna be the same thing, but we're incrementing that piece by 1. So it's gonna be I equals 1 to n, A2i, x, I, and then etc. And then that 2 will then turn to 3, and then it'll keep going until we reach m, right? So that's our function. You can show that's linear pretty easily. I mean, we've seen the criteria for what it means to be linear. But again, since it's a matrix, I think we can get behind that pretty easily. But now what do we have here? Well, if we set this equation equal to 0, that means all these things are equal to 0. So in particular, for example, if we look at the first component, that equals this. I'm just going to rewrite it. X, 1, I equals 0. Well, this looks like part of a linear equation, right? Part of a system of linear equations. Because, for example, if n was like 3, that'd be like a 1, 1, x1 plus a 1, 2, x2 plus a 1, 3, x3 equals 0. And then if we have a bunch of these, then we just get a bunch of linear equations. Okay, so that's how we're relating back to linear equations, but what's the point, right? Well, what happens if the dimension of Rn is greater than the dimension of Rn? Just to relate it back to what we're doing here, well, probably the better question to ask is, what happens if we have more variables than we do equations? Well, what does that mean? Well, how many variables do we have? We have n variables. That's the domain. How many equations do we have? We have m equations. So in particular, if we have more variables than equations, that means our domain has greater dimension, right? Because our number of variables is exactly the dimension of Rn. Then that means we have a greater dimension of our domain than we do of our codomain, right? Okay, well, what does that mean? That means this, right? That's this case. That means t, that means our t as defined here can never be injective. What does it mean to not be injective? That means that it's null space. So that means that the null of t is not trivial. It's not just 0. So there has to be some non-zero solution to this system of equations if we just write this all out, if we set all of these equal to 0. So that's our criteria in particular for when we have a non-trivial solution. That we've essentially just shown, right, that if there's more variables than equations, then we have a non-trivial solution. And that concludes this little funky video. And Sebastian's hands are shaking because he doesn't work out enough. So this is a good little workout for him. I appreciate you, Sebastian. Sorry for teasing you. And theoretical nerd out.